Hello, this is the workthrough for CH342 in semester examination for the academic year 2020-2021, and I hope this helps. So we'll just work through the whole paper. I might have to break the video down into some sections, but we'll go through one by one. So please try the exam paper before you go through the workthrough, and that way I think you'll get more out of it. Okay, so the first section for this paper is the digital electronics part, and the first question itself is a minimization problem using Boolean algebra. So let's just zoom up a little bit so we can see what we're doing. And okay, so there's some simple questions and we just need to find the minimized expression. Okay, part A, we have A not B not C or A, and then this part over here, and we're supposed to minimize this and give the answer. So from here, let's just first expand this all out. So we have A not B not C, or A not B C, or A B. Okay, so as soon as you see this, you'll see that in these two terms you have A, B common and C bar, so that looks like a simple minimization. So A and B bar are common to these two terms, so we just take this term. So you have C bar left here, or C there, and then we have this term left over. So it's A, B. And we know that if you have anything O, it's invert. So we have C bar or C. Then C has to be either high or low. So then this will always be 1. So this always goes to 1. And then this will simplify to A not B or A B. And now we can see that we can simplify this a little bit further as well. So A is common, and then this is going to be B bar or B, and again this also goes to 1, so we're left with just simply A, and that's the answer to the first part. Okay, let's move on to the second part. So now we have A, B, C, or A bar C or B bar C. So when we take a look at this, what you can see is that we can do a few different things. So it looks like the easiest thing to do would be to first find the common term, which is C. So let's take C out, and then we're left with A, B, or A bar, or B bar, right? Okay, and now this we can simplify further if we just realize that these two terms here, so these two together, if we apply the De Morgan's theorem to this part, we know that this is going to be equivalent to what I'm just about to write. So C, A, B, O. So these two, we can say that this is equivalent to A, B. So remember, with De Morgan's theorem, you take what's in between the two inverted parts, you change it from O to N, or if it's an N, you change it to a O. So we had a O here, so it goes into N, and then you distribute the inversion over the two parts. Okay, and now we can very nicely see that these two will just again go to 1, and you're left with simply C. Okay. Okay, so let's move on to the part C. So in part C, what do we have? We have right. So it looks like the easiest way to do this is simply by expanding these. So we have A, and A, which is simply A in Boolean algebra, or A, C, OAB, OBC. And then we have OB bar, OC, right? Okay, so now again, same thing, we can apply De Morgan's theorem for these two, and then we can realize that this is actually BC bar, which then means that you actually don't need to look at anything else. This plus this, all these together, they will also simply just go to 1. So you're actually left with 1. And we're done. Okay, and the final part, D, for question number 1, is we have AB, C bar, AC, BOD, ACD plus BD. So how shall we approach this? And looking at this, it seems you can take, right, well, let's start off with taking this term and this term together, right? So if we take those two together, we have A, C bar, right? And B left over, A, C bar, and D, OBD, plus A, C, B, and D. Right. So whenever you have this, B and D, it's saying this whole part is going to be high when B is high or D is high, or when B and D are both high. This is redundant, so you can just cut this off, because when B is high, right, it's already true, and D is high, it's already true. So this is redundant. You can just cut this part off straight, right? So what you get is you have A, C, B, or D, right, plus A, C, B, or D. Okay, so what do you have here? So this you can simplify a little bit further by saying A is common to both, and then we'll have C and C bar, B or D, and that you can tell this is going to go to 1. So we'll have A, B, D, and that should be the final answer.